Today we're going to talk about trig functions. So if we're going to talk about trig functions, let's first start taking a look at that unit circle that we've spent a good amount of time on already. So if I were to just draw a unit circle over here, and I want to know what is the wrapping function of pi over 6. Well, if you remember, pi over 6 is somewhere over in this region here. So if I'm asking for the wrapping function, remember we drew that triangle. Okay, and we talked about, well, if this is pi over 6 right here, the coordinates of that location are going to be root 3 over 2, comma, a half. And that's one of those points that I told you would be a pretty wise idea to have memorized. So if it's root 3 over 2, that means this side down here is root 3 over 2, and this side right here is a half. So the wrapping function of pi over 6 would simply be root 3 over 2, comma, a half. Now, given that, let's find some of this information over here. So what is pi over 6, the sign of pi over 6 for that location? Well, if we're talking about this triangle over here, okay, and if I'm asking what's the sign of pi over 6, I'm saying, given that this is my central angle, what's the sign over pi over 6? Well, let's remember that sine is equal to, sine is equal to opposite over hypotenuse. So if we look at that triangle over there, opposite is equal to a half. And the fact that it's a unit circle means that this length right here is 1, so the hypotenuse is 1. So sine of pi over 6 is a half. Okay, then let's talk about cosine. Well, cosine, you remember, is equal to adjacent over hypotenuse. So again, looking at this triangle over here, adjacent is root 3 over 2. And hypotenuse again is 1, so it's root 3 over 2. Okay, so cosine of pi over 6 is root 3 over 2. Last one, let's talk about tangent. Well, remember tangent is equal to opposite over adjacent. Well, opposite, as we've already said, is equal to 1/2. Adjacent is equal to root 3 over 2. So let's manipulate this just a little bit here. So that's equal to 1/2 divided by root 3 over 2, which is 1/2 times 2 over root 3 cancels. 1 over root 3, which if you rationalize, you'll come up with root 3 over 3. Okay? So not awful right there. Okay, but given the fact that we know a location like pi over 6, we can use that triangle and we can come up with all these different functions. So let's try one more. Let's say if we talk about the wrapping function for pi over 4. All right, well, if we want to start fresh here, if we talk about unit circle, pi over 4 is about halfway. Okay, it's up here. Okay, so hopefully you have this one memorized. It's root 2 over 2, comma root 2 over 2 is the location. If I were to draw my triangle, it would be this triangle here, like that, meaning that this is root 2 over 2, and this is root 2 over 2. And this again is 1. So you should pause and take a moment and see if you can fill out these all these different parts. Well, if you're trying to fill out the wrapping function, you would just say it's root 2 over 2, comma root 2 over 2. If we're talking about the sine of pi over 4, well, remember sine, as we wrote up here, is opposite over hypotenuse, so that would be root 2 over 2 over 1, or just root 2 over 2. And cosine of pi over 4 is adjacent over hypotenuse, which is root 2 over 2 over 1, which is root 2 over 2. And finally, tangent of pi over 4 is opposite over adjacent, so that would be root 2 over 2 over root 2 over 2, which is equal to 1. Just like that. Okay, so again, not terribly difficult right there. And a lot of that is stuff that hopefully we should have known before. But what I want us to do is I want us to take a look at a couple of observations. Especially with the pi over 6s. You notice that we have this wrapping function up here. One of the things I want you to notice is the relationship between this coordinate and then this answer, and this coordinate and this answer. And the same thing, although it's not quite as obvious because we use pi over 4, but there's a relationship between this coordinate and this answer, and this coordinate and this answer. Okay, there's such a relationship that we can actually make some generalizations, which we're going to do down here. One of the things we know is that sine is equal to opposite over hypotenuse. Well, every time that we did opposite over hypotenuse, we take a look at our unit circle. When we talked about opposite of this angle, it was always this location here. Or if I draw another unit circle, okay, and I draw a triangle, it doesn't matter what the location is. If I talk about opposite, okay, I'm talking about this spot right here. Well, what is that spot? That's always the y coordinate. This length is the y coordinate of this location. So I would say that sine is equal to y, and the hypotenuse is always the radius. Well, if the radius is always 1, that means sine is equal to y. So in other words, the sine function is equal to the y coordinate of the wrapping function. Okay? Well, let's keep going on. What if I talk about cosine? Well, cosine is equal to adjacent over hypotenuse. If we take a look at our unit circle over here, adjacent is this spot right here. Well, that's the x coordinate. Okay, so it's x over hypotenuse is r again, and since r is 1, that means cosine is equal to x. So what that's saying is that when we spent all this time talking about the wrapping functions, when I ask you for like way up here, let's see if I can get rid of some of that stuff. All right, there we go. If I'm asking you what's the wrapping function of pi over 6, and I say root 3 over 2 1/2, okay, what that's saying really is the cosine of pi over 6 is equal to root 3 over 2. And the sine of pi over 6 is equal to 1/2. Okay, so as we are looking at our unit circle, as I'm looking at our unit circle down here, and we have these coordinates that go with all these points, well, that's essentially cosine and sine right there. And that's why we learn all those coordinates of the unit circle, because they tell us what the cosine and the sine values are of those locations. So let's kind of move on a little bit here. So just to keep adding on to things, when we talk about tangent, oops, let's get rid of that. We'll try and stay consistent. When we talk about tangent, tangent is equal to opposite over adjacent. Well, opposite is equal to y, and adjacent is equal to x. Okay, basically that's what we're getting up here, which is also known as sine over cosine. And then the other three functions, cosecant, secant, and cotangent, are just the reciprocals. Cosecant would be hypotenuse over opposite, or r over y, or 1 over y, or 1 over sine. All those things are true. Secant would be adjacent, pardon me, not adjacent. It would be hypotenuse over adjacent, or r over x, or 1 over x, or 1 over cosine. And finally, cotangent would be adjacent over opposite, okay, or x over y, or cosine over sine. Okay, and these are things that we need to desperately know. Those are incredibly important to us. Okay, and lucky for you, we're going to do some practice. All right, so let's take a look at a couple of these. So if I ask you what the secant of pi over 3 is, so what we want to do is this. We're going to take a look, unit circle. Okay, so pi over 3, we'll say it's up in here. So hopefully what you know is that the coordinates of pi over 3 are 1/2, comma, root 3 over 2. And so if that's the case, that means the cosine of pi over 3 is equal to 1/2, and the sine of pi over 3 is equal to root 3 over 2. Now that doesn't answer our question. The question is, what's the secant of pi over 3? Well, secant is equal to 1 over cosine. So therefore, if cosine of pi over 3 is 1 over 1/2, that means this is equal to 1 over 1/2. Okay, which is equal to 2. So the secant of pi over 3 is equal to 2, just like that. All right, let's take the same kind of idea. What if I ask for cotangent of pi over 3? Well, let's go back and let's talk about what's tangent of pi over 3. Well, tangent of pi over 3 is going to be opposite over adjacent, or also known as, now forgive the sloppiness of this, but tangent is equal to sine over cosine of pi over 3, that is. So that's root 3 over 2 over 1/2, which if you simplify becomes root 3. So why do we care? Because cotangent is equal to 1 over tangent of pi over 3. So therefore it's equal to 1 over root 3, which is root 3 over 3. Just like that. All right, let's try another one. Okay. How about, let's get rid of some of this stuff here. Okay, so let's look at sine of 2 pi over 3. So let's go unit circle again. So 2 pi over 3 is over here somewhere. All right, well, let's see. The coordinates for that location at 2 pi over 3. Okay, let's see. It's going to be 1/2 root 3 over 2. But because we're in the second quadrant, it'd be negative 1/2. So what's the sine of 2 pi over 3? Well, that's the y-coordinate, so it's just root 3 over 2. Just like that. What about tangent of 7 pi over 2? 7 pi over 2 here. Alright, so where is that? Well, 7 pi over 2 is the same thing as 3.5 pi's. So if I look over here at my unit circle, I go 1 pi, 2 pi's, 3 pi's, and 1/2. So 7 pi over 2 is down here. So the coordinates down there are at 0, -1. So tangent is sine over cosine, or y over x. So it's -1 over 0, which is undefined. Okay? So we should be able to come up with any trig function based upon that unit circle if you know your coordinates and if you know all those ratios. And the big ones are the fact that if you know cosine is equal to the x-coordinate, sine's the y-coordinate, tangent y over x, and then all the other ones, secant 1 over cosine, cosecant 1 over sine, cotangent 1 over tangent. Okay, last thing. Let's take a look at this down here. What if I gave you something crazy like this? What would you tell me? All right, take a minute and see if you can come up with all those. Okay, so let's see. If we talk unit circle, and don't be afraid to draw just a bunch of unit circles on your paper just to get an idea. So pi over 2 is up here, so this would be at 0, 1. So cosine of pi over 2 would be, that's the x-coordinate, so that's 0. Pi over 3 is over here, and the coordinates for that would be 1/2 root 3 over 2. Well, not that we care because 0 is going to cancel it out, but the sine of pi over 3 would be root 3 over 2 minus the cosine of pi over 3, which would be the x-coordinate of this spot, which should be 1/2, and the sine of pi over 2 up here, which would be, up here, which should be 1. So what does all that equal? Negative 1/2. So I can give you some complex looking trig expressions just like that, and again, using your knowledge of the unit circle, should be able to come up with all these different values. Okay, well, that's it for now.